Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk about bringing out the big guns. We're going to show you how you can use a debugger in order to reverse engineer some malware. As before, you're running this stuff, make sure you're running it inside of a virtual machine sandbox or a not network connected physical machine that you're using as a sandbox. Never run this stuff directly on your forensics workstation. So if you're new to the new debugger, GDB, you're in luck because guess what? You're here at Pentester Academy, and at Pentester Academy, we have an awesome tutorial on how to use GDB. So I would never attempt to repeat that entire tutorial. It would be somewhat pointless. Vivek did an awesome job delivering that particular video series. Well, let's be honest. All of the video series that he's developed here at Pentester Academy. Pretty awesome. So I just wanted to give you a couple of pointers and talk about how things might be a little bit different if you're doing some reversing. The other thing I feel that I should point out is that you can get debuggers that are optimized for reversing. Things like IDA Pro come to mind. Now, these are great tools. However, they are far from free. IDA Pro, the pricing starts at around $1,100 US. And that's the entry point pricing. So if you are the person that might just occasionally have to do some forensics on a Linux system, or if you're doing this as part of an internal investigation, you probably can't justify dropping that kind of money unless you're a professional reverse engineer. So we're going to talk about using the standard debugger, GDB. So how do you use it? Well, it's pretty simple. Just fire it up, GDB, and you give it the name of your executable. So we'll start with our bind shell. And there you have it. We're running GDB. It says if you need help, type help. And you can also use apropos to search for commands related to a certain keyword. It's command line based, but it's also very powerful. And once you get used to it, it is pretty good. Again, if you're not familiar with GDB, I highly recommend that you stop this course, go to the GDB course, and then come back. A good thing is that we've managed to learn quite a bit about our unknown files without having to resort to bringing out the big guns. One of the first things that you're going to notice is that you have no source code in most cases, so you get to look at assembly. Now, most people seem to like the Intel assembly style versus the AT&T. Now, AT&T is the default on GDB. You can easily change this with set disassembly -flavor Intel. So now when you disassemble something, it will be a lot simpler. So how do you disassemble something? GDB allows you to shorten commands. So if I just type dis as, and I can even hit tab, it will complete it for me. And I can give it a function, a memory address, etc. If I just hit enter, it's going to tell me, I'm sorry, I don't know what to disassemble. So let's go ahead and disassemble main. And it's going to disassemble the first few lines of main. Now, one thing you'll learn about right away, if you take any of the shell scripting classes / assembly classes here, is that there's different calling conventions. And in most calling conventions, you will see things are allocated on the stack whenever a function is called. And that's what these first few lines are doing here. First, we're pushing the frame pointer, which is RBP. You might be used to EBP if you've done 32-bit assembly. This is a 64-bit program. We push that on the stack. We move the stack pointer to the frame pointer. Recall that in Intel syntax, the destination comes first, which is somewhat reversed from what you're used to. We then push the frame pointer onto the stack. We subtract 8, allocating memory on the stack, and then you will see a bunch of things moved onto the stack, and that's what's happening here. Finally, after all that is done, you will see a value moved into EDI, and then a function is called. In this case, it's nmalloc. And then some other things are moved around, and another function is called. So if you really start studying reverse engineering, you will see that a lot of understanding what's going on is just understanding the different calling conventions. Now, because this is a 64-bit program, a lot of the parameters are not passed on the stack. They are passed in different registers in the CPU. So here, I'm passing a parameter, and I'm calling a function. If I hit return, it will continue my disassembly. And see here, it's moving some addresses, and then it's calling another function. You might notice that this looks very similar to our ltrace/strace that's just all combined together. Again, here you can see we're doing a move, and then we compare what we moved to 0. And depending on what happens there, we're either going to jump ahead all the way down here, or we're going to keep on going and make some more calls. So we still haven't run this. Now, in theory, if you promised not to actually run this code, you could do this outside of a sandbox. You could do some disassembly, but I think it would be very foolish to do so, because you could easily accidentally start executing this code. And if we go a little bit further, we can see some of the other code here. There's a call to daemonize. We're writing our process ID to a file, etc. We create a socket. We have a write, a call to htons, and so on we go. We set some socket options, some more writes. We call bind, fwrite, exit, listen, another write call, a flush call, an accept call. We're comparing some strings. We're checking the string length. More writes and reads, etc. So we haven't actually run this just yet. So far, we've just went through some of the disassembly. And finally, we've reached the end of our program, the end of our disassembly. So essentially, we've done a static analysis, if you will, and we've done a disassembly of our program inside of GDB without running it yet. And that's something we'll do in a future video. So that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.